Alright, what's up everybody? Hopefully this music isn't too loud. Let me change the volume here. But, as you can tell from the title, today we're gonna go over something a little bit different. So last stream I went over the old standard level math paper. And we went through it, and there's some things that have changed. And normally after I go through a standard level, I go through a higher level. But the higher level curriculum has changed quite a bit. So I didn't really want to go through an old paper. So instead, today we're going to go over Revision Village. They have a set of free papers. And we're going to go over their practice paper 1. We'll see how long it takes. And then I wanted to try out playing this game because I figured it might be interesting. And of course, throughout all of this, well, anyone's welcome to ask any math questions. But yeah, so let's see. Revision Village is the more or less #1 IB math resource. Although to get access to most of their stuff, you need a paid account, but they do offer some things for free, which is pretty good. I do have a personal account, but I'm not going to use that because, well, you know, that's illegal. However, if someone wants to tweet me their so-called repository of Revision Village stuff to use, then I don't mind. But oh well, let's get this started. Never mind, hold on, can't paste. Okay, so here we go. We have Sophie, and she's going to randomly select one chocolate from a large box. And then there's different types and sizes. We have sugar-free, we have king size, we have the probability of these. And then we need to find the probability that the chocolate she chooses is not a sugar-free king size. So neither sugar-free nor king size. So for these types of questions, I recommend you always draw a Venn diagram. So it's pretty clear that there's an overlap between the chocolates. So let's say you have your sugar-free and then your king size. So sugar-free is 0.6, and then I know this is higher level, so this is probably going to be less of an issue for you guys, but do not put 0.6 in here because that's not quite correct. 0.6 represents, of course, the entire probability, whereas if you put the 0.6 in that where I just wrote it, then you're essentially implying 0.6 is just sugar-free and not at the same time king-sized. But anyways, the third line is important. We have sugar-free is 0.8. Now, that means that, or the sugar-free or the king size is 0.8. So that means that these two probabilities together is 0.8. And then if you take a look at the individual probabilities, those add up to 0.85. So what that means is that there's an overlap, and then there are some chocolates that are both sugar-free and king size. And luckily, well, if this is 8.5, and we know that altogether it should be 0.8, then that means that the overlap is 0.05. And then from there, we can calculate the probabilities in each of these parts of the diagram. We know sugar-free is 0.6. So that's 0.55. And king size is 0.25. So over here is just 0.2. Hey, Snake Star. You had a test the other day, right? Last week? I accidentally asked some other snake-related user, and then they had no idea what I was talking about. But I'm pretty sure it was you. How'd it go? So anyways, now that we filled out this probability, of course, we know that the entire Venn diagram needs to be added up to a probability of 1. And what we want to find out is this last piece that I haven't filled in. Not sugar-free or king-sized. So we want to find out the probability that lies outside of the circle. However, that's pretty straightforward because I already found out all of the probabilities inside the circle. So I just take 1, and then I just subtract each one of these. Went well. Tough question for the entire class. Struggled with it. I feel like if I could just focus on math, would have went better, but there's a lot of IB stuff going on. Yeah. Welcome to IB, where every course thinks that it's the only course that you're taking, and then they just give you a bunch of stuff at the same time. Very similar to post-secondary, actually. So if you can get through this, you're pretty well prepared for post-secondary. And like, don't sweat it, because they know you are busy, and the grading boundaries are very generous, or at least historically they have been. Ugh, and then this is a paper 2, right? Or paper 1, so I can't even use a calculator. Okay. This is 1, subtract. What is this? 0.062? You got your math IA done though. Oh, nice, congrats. I hope it's good. And I hope your teacher will give you good feedback on it. Anyways, not sugar-free, not a sugar-free king size. Hold on, so not sugar-free and king-sized. Okay, I see what this means. So ignore what I just said earlier. You just don't want it to be this, essentially. So we are gonna take 1 and subtract all of that. So ignore what I said about finding. What I was trying to find out was not sugar-free and also at the same time not king-sized. But this specifically says not sugar-free king-size, so we just take 1 and we subtract the probability of being a sugar-free king-size. So 0.95? Sure. And then question 2. Your standard solve for x log question. Let's see. I would like to collect everything together, but first I have some questions. Hi, I have a question about the Desmos project. How would you like to hand it in? Well, first, hello, Oliver. And second, you just leave it because it automatically saves and I have access to the Desmos activity. So I can just look at it anytime I want to. So don't worry about it. It's automatically handed in. So a typical log question. I personally like to collect all my logs. So I would have log base 5 of x minus log base 5 of 4. And then that log base 5 of 3 on the other side, I would subtract over. And I would just leave the 2. And then we just use your log rules to consolidate everything into one log, because they're all of the same base. So I would take the x and then I would divide by the 4 and by the 3. And this is equal to 2. So in other words, what this is saying is that if we convert this to exponential form, 5 to the power of 2 should result in x divided by 4 times 3, which is 12. So 25 is equal to x divided by 12. In other words, x is 25 times 12. So that should be, I think, 300. And what's nice about Revision Village is they give you the mark scheme. So on average, if you have like 5 minutes, well, you should take 5 minutes for this. Hello, Milky You. But I'm going to be honest. The structure of an IB paper is pretty straightforward. You have like 1 to 6 short questions, anywhere between like 5 to 8 minutes or marks. And I think that those are pretty generous in their timing. I know the first question says 6, and I know that this one said 5, but I think each one you should realistically only take about like 2 to 3 minutes on. And you obviously want that little bit of buffer time, because the longer questions, you know, you want to spend more time on those because they're worth more marks. Okay, next one, number 3. And I know, maybe, is it too soon to get out of my niche? Maybe you guys can help answer that. Because, like, my niche is math help, right? And there's only a handful of people on Twitch that do math help. But I wanted to play this game later because it seems kind of fun. And it's semi-related to math. I think it demonstrates good qualities of what math is trying to teach you in school. So I figured it'd be fun to play because it's a puzzle game. But we'll get there when we get there. I want to get through this first. Okay, so let's see. We have this quadratic equation, and then it has 2 roots, alpha, beta, such that alpha squared plus beta squared equals 6. And then we don't want to solve the equation, but we want to find out possible values of this real number k. Okay, so because this is HL, and because I stream playing Sudoku, nah. And because I just taught this to my actual class, this I know right away has to do with Vieta sums. So these 2 formulas right here. So if you have a polynomial, Nick Zuby, thanks for the follow. Although I don't know why my chat alert box is muted right now. Quite woke, thanks. Yeah, do you guys hear the alert box? Because I can't hear it right now. I guess I'll look into it in a bit, and I just gotta keep my eye out. So when you have a polynomial and it has sums, or roots of course, then when you add them all together, it's related to the coefficients in the actual polynomial itself, and also when you multiply the roots together, it's also related to the coefficients in the polynomial itself. So in other words, I'm going to copy paste this because I never remember this one. So what this means is that my two possible roots are alpha, beta. So if I add alpha and beta together, then this is equal to negative the second term, which is negative k, divided by the first term, which is just 1. In other words, alpha plus beta is just k, so that's nice. And at the same time, we can use the second Vieta sum, or, well, not sum, but the second Vieta formula, and that says that the product of the two roots is, well, negative 1 to the power n is the degree, so negative 1 squared, because we have a quadratic. The last term, which is the constant, so k plus 3, or sorry, k minus 3, and then of course divided by 1. And then all of this more or less just simplifies into saying that alpha times beta is k minus 3. Okay, going off of this stuff, now we know something. This part we haven't used quite yet. And it's kind of a cheesy technique that really only works in this type of situation. But what we're going to do is we're going to look at this polynomial. Alpha plus beta squared. If we were to expand this out, you get alpha squared plus 2 alpha betas plus beta squared. Now, what's nice about this is, well, we know a couple of things. One, alpha plus beta squared, well, alpha squared plus beta squared is 6. So that means that this part of our formula is equal to 6. I know that this part, alpha plus beta, I figured out earlier is k. And I know that this part, alpha times beta, is k minus 3. So after I make the substitution, I'm going to have an equation just in terms of k, and then I can solve for k. So here. This becomes k squared. I get a 6 from these two. And then I make a substitution here. And this is pretty easy to solve. We have a quadratic for k. So let's just make this look a little bit nicer. And then let's see, well, those will be 0. And then if I just collect things to one side, after the fact, I get this. I can factor out a k. So I have two possibilities, 0 and 2. Oh, and while I actually still have viewers, I wanted to show you guys something. So last stream, Cat Hospital asked me to check my Twitter, and because I reformatted my computer, I didn't have the login saved, and I can't remember the password off the top of my head. But I logged in to check out what they tweeted me, and it's pretty cool. So let me show you guys. So this person made art of me, So I've actually changed my profile pic to this because that's pretty cool. This person, who goes by Cat Hospital, Miss Gomin. And what's funny is that I don't quite recognize them, so I don't even think that they're one of my students. So this is just some person that found me on the internet and decided to draw me. Artist application. Very strong resume. Very happy. Crazy. So thanks again, Miss Gomin / Cat Hospital. Made my night that night. Okay, moving on though. Totally looks like me. Yeah. Part of me wonders if like they just took a screenshot and then just like slapped a drawing filter on it to make it look like it was drawn. I mean, I don't think that's actually how it happened, but you know, that just speaks to how good they were. Okay, so let's see what I'm doing now. I need to show that this integral will become this. Okay, easy peasy. We just need to take an integral. So we have an x squared multiplied by a natural log of x. And, well, at HL level, you have more integration techniques. And you should be able to tell right off the bat that this is not a substitution question, U substitution. Best thing to do is probably integration by parts. So let's see what we can do. If I set, so I need to choose one of these factors to be U and one of these factors to be dV. Now, if I were to choose the natural logarithm of x to be dV, well, then I have to integrate it, which is probably in your formula book, but I don't think that's the right way to go, because if I make u natural log of x and I make dV x squared dx, then what happens is v is going to be 1/3 x cubed, and then taking the derivative of natural log x is quite straightforward. That's 1/x. And then this is nice when we pair these two together, because this x will divide with this x cubed. Oh, Goldilocks, I haven't seen you in a while. How are you? Okay, so what we're going to do is this integral becomes u times v, so natural log of x times 1/3 x cubed evaluated at 3 and 2. Been studying for econ and stats. Do you teach econ or stats? No. Snake Start. Oh, yeah. I became an affiliate for those that haven't tuned in recently. So Snake Star has my custom emote. Econ or stats? No. Maybe you could ask me a possible stats question, but honestly, I don't like stats. So unfortunately not. Okay, and then from here, let's see, the second part of the integration by parts. I have 1/3 x cubed times 1/x dx. Contingency tables. I have no idea what that even means. But if you're saying it's not too complicated, then I guess that means that you're good, aren't you? Okay, so let's see. Let's evaluate this part. So 1/3 I'm gonna do it like this. Natural log of 3 times, I'm just gonna plug everything in and then deal with this later. Natural log of 2 times 2 cubed. I'm not a doctor. I don't have the brains for the doctor. And yes, that is the GF. And then the integration part, well, I can pull out the 1/3, and then what's nice is that it just becomes, this x will divide with one of these. So essentially, what I need to integrate is I need to integrate x squared. And then there's a 1/3 coefficient, which is fine. We'll just leave that out in the front. So that becomes another 1/3 x cubed. And let me use square brackets. And then this is evaluated from 3 to 2. And now we just need to plug in more stuff and get on with it. So 1/3 times, well, 3 to the power of 3 is just going to be 9. So I have 9 natural log of 3. And then this part right here is just 8 over 3. When everyone wants to be together but not in the auditorium. Yeah. And then from here, the 1/3 and 1/3 make 1/9. And then essentially I'm just evaluating this at 3 to the power of 3, subtract 2 to the power of 3. Yeah, but you see, the issue with the cafeteria is, again, the projection of my OneNote. Where am I going to project? How large can it be to make sure that everyone in the caf can see it wherever they sit? Okay, let's keep going. I don't know how pretty they want this to be, because you can do natural log 3 to the power of 9, and then minus natural log 2 to the power of 8 over 3. And then what the heck is this? 27 minus 8. And then this just becomes 19 over 9. And then of course you can combine your natural logs together. And this looks so weird, but maybe this is the answer. Can't I rearrange some tables? Yeah, the tables all have wheels on them, so those can always move around. And then we have a screen that we use every once in a while for awards down in the cafeteria, but it's tiny, super tiny. There's a wall that might be a possibility to project onto, but again, I need to do some more research into that. Yeah, so then for those that don't know, because of COVID, my particular school is limiting the amount of students that can be together to 15. And so if you have a class that's over 15, it gets split up into 2. But the class I have is around 20, and so it's close but not quite enough. And I figure it would be more efficient if we just could be together in a larger space, properly, separated from each other. So the option was we go in the cafeteria or the auditorium. The issue with the auditorium is, if you guys have ever been in an auditorium, there's not a lot of table space. And the issue with the cafeteria is exactly what I just said. Anyways, enough about work. I'm off the clock and I don't want to think about it. Let's do this one. We have 5 equilateral triangles, each with a side length of 4, and then they make this truss bridge. And then we have vectors A, B, and C, and then we need to find A dot A plus B plus 2C. So this is actually, I think, a question from a former HL paper that's carried over to here. But what we're going to do is we don't actually need too much fancy calculations, and we need to think about this geometrically. So you got to think about what A plus B is as a vector. Here's A, and then we add to it B, which has a resultant vector of C. So A plus B is actually C. So in that bracket, we actually have C plus 2C, which of course is 3C. And in the picture, well, that's 3C. And then all we need to do is we need to find the scalar product of A with 3C. So there's A, right? And here's the thing, A is 4, they told us it's 4, and 3C is, well, 12, because each length of C is 4 as well, so that's a total of 12. And then we just go to our formula book, and we find the formula for scalar products. And we're going to use this one. V dot W is the length of V times the length of W times cosine. So this is the length of A, which is 4, times the length of C, which is 12, times cosine of the angle. So then this is the last bit that we need to find out, the angle in between the two vectors. Now, of course, what's nice is, well, this is an equilateral triangle right here. And then, well, equilateral triangles always have internal angles of 60 degrees. I guess I'll use radians, which is pi over 3. So that's that last missing piece. So this is cosine pi over 3. Where do I see myself in 20 years? I'm going to be pretty old by then. And what's my dream career / place in life? 20 years. I don't know. If I was, I'd still be teaching, because the average career of a teacher is about 30 years. So I'd still be teaching in school by then. But I don't have a dream career. My dream is to not work. I don't think that'll ever happen though. But realistically, you know, I'd like a larger place. I'd like a nicer car. I would like to still be fit and healthy and happy. That's the realistic answer. Anyways, cosine pi over 3. We also know what this is because that's a special angle. Yeah, win the lottery. Gosh, if I win the lottery and it's like over 6 million, I'm not gonna step foot into my school again. And these kids are on their own. I'm gonna start living my life. What are the chances of winning the lottery? 1 in like 13 million. It depends on what kind of lottery you play. I still play because, you know, you don't win if you don't play. It's just don't get your hopes up. Okay, I never memorized this, so I always need to write this down, which is kind of sad, but... Look, a lottery ticket in where I live is like $3. So I can play like once every 2 weeks. I spend more money on like coffee. And you know what people say? They say that money is not an investment. What it is it's like entertainment. Like how you pay $10 to go see a movie or $15 nowadays. You pay $3 to, in your head, live out the fantasy of what you would do when you win all that money. And that keeps you entertained for a decent amount of time. I say it's worth the $3. Anyways, back to this. Okay, so this is 4 times 12, which is 48. And I'm going to multiply this by cosine, which is root 3 over 2. So 24 root 3. Yeah. Okay, moving on. Copy. Thank you, Jenny Yeehaw. Yeah, I don't know what's up with my alerts right now. They're not sounding. And then, wait, Snakestar, did you subscribe and then I just missed it somewhere? Gaming stream? I don't know. Soonish. Maybe after I finish a couple more. I don't know. I'm not playing Valorant. I'm never gonna play a shooting game. I hate shooting games. Okay, we're gonna expand and simplify 1 plus root 3 all squared. Shoot you 1 month ago? Oh, has it been 1 month already? There you go. You got shot. Okay, we're gonna square this, so we get 1 plus 2 root 3 plus 3, which simplifies to 4 plus 2 root 3. Man, rip cool math games. Is there like an alternate site for those games? What was the one that everyone plays, the running one where you jump? Anyways, okay, next up. By writing 75 as 30 plus 45, we need to find the value of cosine 75. So cosine 75, we're going to write as 30 plus 45. I will never touch League of Legends again. Never played TFT. I don't know, I have a particular taste in games, and those don't fit into it. Okay, so what we're gonna do... Yeah, I know one of my students is... Oh, not for TFT. That's crazy. I look like a StarCraft type of gamer. Are you profiling me because I give off, like, I don't know. Some people say that I give off Korean vibes, and I think it's the dyed hair. Which is, you know, touch racist. But, okay, they tell you to write this as an addition, which is a very strong hint that we're going to be doing identities. So there should be a cosine addition identity right here, which I never bothered to remember. But we just plug this in and then we go with it. It's the hair, but also the affinity for math and logic. Yeah, but StarCraft isn't about any of those things. It's all about what? Your... whatever it's called, something PM? APM? I don't know. League has just been not a good time overall. And everyone I talk to just is not a fan of League. Like, I don't know if they've made things different, because I haven't paid attention to League in like years, but a while ago it was just so bad, so toxic. And like everyone says, it's not even fun, especially if you lose. It's almost as if you just like lost 45 minutes of your life, because it's not fun when you lose. It's incredibly frustrating. You gotta have the right mindset. Anyways, I'm drawing this because again, I just cannot pull this out of my head right now. So cosine 30 is what, root 3 over 2. Cosine 45 is 1 over root 2. Sine 30 is 1 over 2. Sine 45 is 1 over root 2. So then I have root 3 minus 2 root 2. Subtract 1 over 2 root 2. Because these have the same denominator, I can write this as root 3 minus 1 over 2 root 2. And then I don't know if IB would prefer a rationalized denominator, but let me just do that real quick. So multiply the numerator by root 2. Multiply the denominator by root 2. Do you guys need send teams to math challengers? What? No? No? Okay, then let's see what we have on top. We will have root 6 minus root 2 over 4. Sure. Okay, so we figured that out. And then in this diagram, let's see, we have this triangle. Okay, sure. And then we need to find the length of AB in this format. So AB is right here, from here to here. And given our information, we can use Cosine Law. So AB squared is equal to 2 squared plus root 6 squared minus 2 times 2 times root 6 times cosine 75. Okay, so let's work through this then. So this is 4, this is 6, this is 4 root 6, and then from the earlier part, I know what cosine 75 is. It's all of this stuff. So this is 10. This 4 and this 4 cancel. And then I take a negative root 6 and then I multiply it in. So then I'll get a minus 6 plus root 12. So I have 4 plus root 12. And then this is AB squared. So then AB is the square root of this stuff. And then I want to write this as a whole integer plus just the square root. Okay. So I use part B right here. And then what I'm going to do is I'm going to actually use part A right here in just a moment. First, I need to simplify the root 12. So this is our answer from part A. If I take 1 plus root 3 and I square it, I get 4 plus 2 root 3. And then the question says, well, what's the square root of 4 plus 2 root 3? Should be this. Nice. What level of maths is this? This is IB, higher level. So, quite difficult, I would say. Alright, let's see. We have a system. And then we don't know what this is. And then let's see. Oh, we don't know A and B. Okay, there's a B as well. And then find the conditions on A and B for which the system has no solutions, one solution, or an infinite. Okay. So what we're going to do is we should write this as a matrix and reduce the matrix. Let's see, where's the best place for me to write this? Right here. So I have 1, 1, 4, 1, and then I have 3, 2, 16, and 5, and then I have 4, 2, A minus 1, and B minus 4. Okay, and then we need to reduce this, so I need to make, whoops, this 3 and 4 0 using some row reduction. So I'm going to take row 2, and then I'm going to subtract 3 of row 1, and I'm also going to take row 3 and subtract 4 of row 1. So I'll have 1, 1, 4, and 1. And then I have 0. So what I'm doing is I'm going to take 2, and then I'm going to subtract, well, 3 times 1. So 2 minus 3 is negative 1. 16 times, well, okay, 3 times 4 is 12. So 16 minus 12 is what, 4? And then 5 minus 3 is 2. And then I have 4 minus 4, right, so this has got to be 0. I have 2 minus 4, which is negative 2. And then I have A minus 1 minus 16. So then this is A minus 17. And then I have B minus 4 minus 4. So B minus 8. And then I need to make this a 0. Was this a review question? Well, I hope you did it right. And then I'm going to take row 3, and then I'm going to add, or not add, I'm going to subtract 2 of row number 2. So what do I get? I get 1, 1, 4, 1, 0, negative 1, 4 and 2, 0, 0. Okay, and then I have A minus 17, and then 2 times 4 is 8. So negative 17 minus 8 is minus 25. And I have minus 8 minus 4, which is 12. Okay. So I've more or less reduced this, and what's important is this last row. So in terms of getting a consistent system or an inconsistent system, if we have no solutions, then basically what this means is you need this thing to be equal to 0, and you need this thing to be equal to anything but 0. So an inconsistent system would have A with a value of 25, and B is any value that's not 12. Okay. And then, let's see. I'm going to skip this one because it's easier to explain the third one first. An infinite number of solutions would mean that this entire row should be all zeros. So we want both of these values to be, well, A to be 25 and B to be 12. And then to have a system, then basically I need this number to be non-zero. So A should not be 25. And then this can be whatever it wants to be. Alright, and then in the case where the number of solutions is infinite, find the general solution to the system of equations in the Cartesian form. Okay, so when we have an infinite solution system, then essentially that means that there's a free variable. In this case, it is the free variable z. So this means z is free. So in equation 2, or row 2, let's say, let's see what it says. That means that it says that negative y plus 4z is equal to 2. So isolating for y, that means that y is... Hold on, what does this question even want? So we need the system of equations in Cartesian form. Okay, so Cartesian form basically means that you have some sort of x equals y equals z business. So because we have a free variable of z, I need to solve y in terms of z, and then x as well in terms of z. So that's what I was doing. Anyways. Here, wait a minute. I have that backwards. I need to solve for z. So z is equal to y plus 2 over 4. And then from row 1, I have x plus y plus 4z is equal to 1. And then, you know what, I'm gonna solve for y as well. So y is equal to 4z minus 2. So in this one down here, I have 4z minus 2 plus 4z is equal to 1. And then solving for, well actually, there's too many things happening right now. I add the 2, collect my z's, and then solving for z. What is z? 3 minus x divided by 8. Okay, so my Cartesian form of my solutions will be this thing. And then it's also equated to this one. then there you go. I want to get to at least the section B questions before I consider playing a game. So, and there's only 2 questions left, so shouldn't be too bad. Okay, I need to sketch 2 graphs, same axes, indicating x and y intercepts and asymptotes. Okay, we'll deal with the linear one later, and then let's deal with this one here. So let's see, let's find y-intercepts. So the y-intercept will be where the x value is 0. So negative 5/2. The x-intercepts, we have none. Because if you just take a look at this, y can never be 0. You have this fraction, and there's always a numerator of 5, so you can't get 0 from that. Okay, and then any asymptotes. So we have a vertical asymptote. Because we can divide by 0. So vertical asymptote at 2. And we also have a horizontal asymptote. As x goes towards positive and negative infinity, the value of this entire fraction will decrease. So y will go towards 0. So I think this is enough information to graph this one. I finished the art project we've been working on for like 3 months. Congrats. Is it good? Am I proud? Always I'm proud. Just because I like to joke around doesn't mean that I'm not happy for you guys. I'm proud of you guys. Okay, and then let's deal with this one. This one's straightforward, right? Let's see. This has an x-intercept at -4. And then it has a y-intercept at -4 as well. Okay, then we can put our little sketch up. So we have a horizontal asymptote. We have a vertical asymptote. We have an x-intercept. We have a y-intercept. This is our linear equation. So that will go like this. And then for our other equation, the absolute value, my only real coordinate is this one, √5/2 for the y-intercept. Or not root, but -5/2. Let's see, 5/2 is what, 2.5? So like right here. And then if you just follow the asymptotes, something like this. Oh wait, whoops, these are at 4. Okay, undo. So 4 is a little bit further out, like here. Whereas this y-intercept is right here. So then it's gonna go like this, and like that. And then over on the other side, well, you have to make a decision whether it goes like this or like this. But that's easy to see if you look at the actual equation itself. This part is always positive, but then it will always be multiplied by a negative. So your range is always negative. So it's gotta look like this. So here's my sketch. And then now I need to find the exact solutions. In other words, where they intersect. You can see that there's going to be two intersections. One for right here, and one for down here. And to do any sort of algebraic solving with absolute values, you always need to split this into however many situations you need. In this case, I need 2. I need to find out what x values make this entire fraction negative and which ones make it positive. And that's easy to see because on the graph it gets split into 2 sections like this. So let's start with the easier one. If x is larger than 2, then this fraction will always be positive. So the absolute value brackets don't actually do anything. So what we can do is we can just write the function as regular brackets. And we want to find out where this intersects with our line, so then they're equal, and then we can solve. So let's see. -5, and then I'm going to multiply and I'm going to factor out a negative here because I don't like negative x. Yeah, so I'm taking this denominator, multiplying it over here, and then I'm factoring out this negative because I just don't want to deal with it. So those negatives on both sides will cancel out, and then if I expand this out, I'll get this, and then I need to solve this probably by factoring because it's a paper 1. Maybe not. This doesn't look factorable. Subtract the 5. Okay, and then quadratic formula then. -2 plus or minus square root 2 squared minus 4 times a times c divided by 2. And one thing to note is when we do the quadratic formula, you should get 2 solutions when there's only 1. And the reason for that is because this quadratic does not accurately represent half of my absolute value. It considers like if there was a full parabola. And we want to probably not do the subtraction one, because that, if I were to subtract it, I bet the x value will be less than 2. So I'm only considering this addition one. And then this is plus 52. And then 56 is, I don't know my times tables off the top of my head. What is this, 9? Not even. 7 times 8. Okay, so here's your first x-intercept, or sorry, x value of your intersection. So that's one solution. And then we need to repeat this process for the other side. When x is less than 2. So that's over here. And then this is something that students get a little confused on. We split an absolute function into two sections. One, where the x values make the inside of the absolute value bracket positive. Because if it's already positive, then the brackets don't do anything. So then we can just replace it with normal ones. And then the other side is, for this particular question, if x is less than 2, this entire value is negative. So what the absolute values do is turn it positive, and we replace those brackets with the mathematical operation that would turn this fraction into a positive, because we know it's negative for these values. So in other words, we multiply by another negative out here. So we know this is negative. This turns it positive, which is exactly what the absolute value does, and then this negative is because it was part of the function. That's this negative right here. So of course those two negatives will cancel out, and then you get this, and we equate this to the other function. And I'm going to skip a step and already factor out the negative. And then very similarly, I have this. And of course, that just means the negative goes over here to make things a little bit simpler. And now I'm adding the 5. And this one is factorable. So you have two solutions for this parabola, which is not necessarily the solutions to our system, or not our system, our question. Because again, this solution only applies for x's less than 2? Oh, actually, there's two solutions. Hold on. Oh, oops. So this one, you see there's two intersections right here. So never mind. These both work. So you have three solutions. 1, -3, and then this ugly one from the quadratic formula. Uh-oh. Low battery. It's okay. We're almost done, I think. Because, yeah, I'm going to do this one, and then I'm going to show you guys a game that I think would be fun to watch. And it doesn't seem like a lot of people need math help right now in the chat. But again, even when I'm playing, feel free to ask. I'll just pause and then switch over to here. Oh, this one does not look fun. Okay, I'm gonna make a substitution into here to show this. Okay, so first, let's see what happens. I make that substitution of x, and then I should change my boundaries. So let's see if on the side here, oh, I think I actually hear that. So Desperate enough. Thanks for the follow. It's just really quiet compared to everything else. My alert sounds. Okay, if cotangent is 1, that's the same as saying that tangent is 1. Phenoixy? Thanks. This is equivalent to saying the tangent is 1, and tangent is only 1 at pi over 4. So this is pi over 4. Whereas if cotangent is equal to 0, this is where tangent is undefined, right? In other words, that's at pi over 2. Okay, well, these boundaries are opposite, not quite right. This one's larger than this one. So what I'm going to do is change them. So this is equal to the negative of the reverse boundaries. There you go. Alright, so let's see what I'm actually gonna try to do. I need to show that this becomes sine squared. And this negative needs to go away. Okay, trig identities. Cotangent squared plus 1 is a big hint right here. So I should probably change it to cosecant squared. And then I think everything more or less just falls into place afterwards. Should change these to d thetas. So cosecant's nice because that's the reciprocal of sine, right? So then I'm taking the reciprocal of the reciprocal. Do you ever just forget that it's 2021? And like, what? I think that it's still 2020? Yeah. Usually for the first week or two. But this is like the 4th week of January, so it's kind of settled in. Okay, and then we get here. And this is a little issue because right now I already have the sine squared part, and then I have this extra squared part, and I have a minus. Okay, did I screw up somewhere? So I make this substitution here. So then I get this. So here is the identity. And then I end up here. But I need to show that this is equal to this. Do I need to use another identity? I don't see how that's possible. Ugh. Alright, so last question. I'm just gonna cheat. Oh, I'm dumb. That's why. Oh my gosh. Silly me. I forgot to do the proper substitution. And I forgot to find out what dx is in terms of d theta. Oh my gosh, I should have known that when I was changing this. Derivative of cotangent is what? 1 over secant squared? Negative. Ah, okay. See, everything's falling into place now. So when I make this substitution, this should have been negative cosecant squared over here. Copy this. Paste that. This negative and this negative are going to cancel out, so that's gone. Okay, and then basically I have cosecant squared on the top, and then I have cosecant to the power 4 on the bottom. So that will simplify into cosecant squared still on the bottom, and then this is it. Jeez, silly me, rookie mistake. Okay, last question, and then I'm gonna start up this game. Hence, find this value. So I guess I just gotta calculate this, right? Now, how do I integrate sine squared theta? Integration by parts won't work, I think, because it's just gonna keep being cosine squared and sine squared. You could use an identity, I guess. Let's see what's good. So I can use the Pythagorean one, but then I'm just gonna have cosine squared, which is the same issue. I can do this one, but then I end up with cosine. if I do this one, then I have this one minus 1/2. And then I need to integrate this part. This part is fine. Okay, I think this is it. So we're going to use the fact that cosine 2 theta is 1 minus 2 sine squared theta. And then we can then write sine squared theta as 1/2 minus, actually, let's write it like this. 1/2 1 minus cosine 2 theta. And then we can pull the 1/2 out. And then take the integral of each part. So then this just becomes theta minus 1/2 sine 2 theta. And okay, so let me just double check. If I take the integral of this, that's 1. I take the integral of this, I get cosine. And then chain rule that 2 multiplies with this 1/2 so that I get nothing. Okay. Yeah, okay, and then we're done, basically. Plug everything in. And evaluate. Sine pi over 2 is 1. Sine pi over 4 is 2√2. And then what do I have? I have pi over 2 minus pi over 4, which is another pi over 4. And then I have a minus 1/2, and I have a plus √2 over 4. Man, this is such an ugly answer. And then I'm done. Man, that took me longer than I thought it would. Okay, so the plan is, at this point, I have 1, 2, I have about 40 minutes of HL questions left, which I'll save for next stream. And then what I really wanted to show you guys, unfortunately RGPT hasn't shown up yet because I wanted to try out this game and see how it goes. I think I mentioned it before, but it's Baba is you. So let me change first my title and stuff. First, play close this up. Close this one up. And then pause the music. Open the game. And then let me just double check how audio is doing. Okay, so this is Baba Is You. It's a puzzle game. And start a new game. Do I want to watch the intro? Sure. So that's Baba. And then those are walls. Those are rocks. There's the flag. Yeah, gaming stream. Okay, so look. Baba is you. Well, Baba is this creature. And the flag is win, which means that if I, as Baba, touch this flag, I will win. The wall is stop, so you can see I cannot walk through the wall because it stops me. And the rock is push, so that means that I can push rocks. So the premise of this game is basically we need to get to the flag. So if I touch the flag, I win. Nice. And then let's go to world 1. And then, well, if you take a look at this, the wall is stop. Baba is me. And then the flag is nothing because we need to basically make a sentence. So as you can see, I can't do anything because the wall is stopping me. Except you see, the sentence that is not always pushable. Basically, the sentence determines the setting of the game. Now, as it stands right now, this sentence says that the wall is stopping me. But if I break this sentence, now you see the wall no longer stops me because there's no sentence saying that it stops me. So now I can go anywhere I want. And then, of course, the flag does not make me win because the sentence does not say that the flag is win. So what I can do is make that sentence. And then now, I have won. And then these get really funky. And you'll see. Okay, so let's look at this. The wall is me. So I'm not even Baba right now. I'm this piece of wall. The flag is stopping me, so I cannot leave this until I break the sentence. So the flags no longer stop me. And then it says here that Baba is win. So if I were to make Baba is win, the sentence, well, now I just need to touch Baba and then I win. Issue is, Baba is not even on this screen. So logically, that means that I need to make something else win. For example, if I make flag is win, now every single flag on this stage is a winning objective, so I can just touch anywhere. Okay, so this is kind of why I like this game. You have a set of facts and a system of the game. And then you just kind of logically go through it to solve the system. So right now, you have these. Baba is me, and then wall is stop. And what's funny is that they are blocked off in an extra wall. So I actually can't touch these at all because the wall is stopping me from going to mess with the sentences. So basically that means that I'm always going to be Baba. And wall is always going to be stop. Now let's see. The water is sink. So that means that I die. If I touch it, I sink. In this lower corner, I have the rock is push and the flag is win. So I can push the rock, and then if I push the rock in, the water, well, sinks the rock, and then the water goes away. So that's nice. And then the other issue is, well, the flag is win. The flag is surrounded by water. It's surrounded by at least 2 squares of water. I only have 1 rock, so there's no point in me pushing it. However, remember, we can change sentences. So what I'm going to do is I'm going to change the rock into the win condition. And then now this rock over here makes me win. It's a fun game. Okay. Let's see. Rock is push, so I can push these. Flag is win, Baba is me, skull is death, so that means that if I were to touch it, I die. So logically, I have no choice but to at least push out the rocks this much. Now, if you look at this, there's no way for me to actually interact and push around this sentence to change it. So just like with the last one, flag is always going to be win, and then Baba will always be me. So then, let's see what I can do. Well, now I can't push the rock. I can't do anything with the rock. And I can't interact with this. So there must be something else. I didn't mean to push that. So this is my plan. I need to play around with this sentence somehow. The only thing I can make it play around with is these sentences up here. So look at this. I think this is gonna work. If I say that Baba is you, and then Baba is rock. Wait, I think I just died. Restart. That did not work out as I planned. Let me see. I can push this. Oh, there you go. Easier than I thought it would be. I just push the rocks and then I break the sentence, so now I can touch as many skulls as I want. And then I win. Man, I can't believe I've lost streamers or viewers since I started playing. Okay, there's no sentences behind me, but let's see. Baba's win is me. Rock is push. Wall is stop. So wall is surrounded by this lava. Lava is hot. And then Baba is melt. So we'll see what we can do. So if I were to break this sentence, then Baba is no longer me. And then you see, I can't control Baba anymore. But I need to get through, so I gotta push it to the side. And then I can't make flag is win, because flag is win is on the other side of this lava. So look at this. If I touch it, I die because I melt and lava's hot. And then I can't play around with these guys. I can realistically only play around with this is, the push, and the lava. So I could change this so that it says that lava is push, but it's still hot. So oh, I can just push it through. Never mind. I thought that I would melt, but I can just push it through and then touch the flag. And I watched this streamer a couple of months ago play this, so I know how to do some of these puzzles, especially the opening ones, but I want to show you guys a different way to do this one. So look at this. I just changed the sentence to Baba is lava, so any sort of lava is now Baba. And because I'm still Baba, I control all of them. So I can win this way. Okay, so let's see what this is. Wall is stop, Baba is me, rock is stop, and then see, notice how the rock is inside, the rock is stop is inside this rock barrier, so I can't play around with these guys. So let's see, first off is I need to get out of here, so I'm going to break the wall. And then if I play around with this, then I automatically lose because, well, Baba will never be me, right? And I can't play around with these. So the only thing I can realistically do is do what I did in the last puzzle. Oops. And I'm going to make Baba is the wall. Wait a minute. Did I just die? Shoot. Other way around. And now, all the walls are Baba, so it's okay if I run into the skull and die, because I have all of these other Babas to touch the flag with. Oops, I think I just moved the sentence. So yeah, I just make sure I touch it over here. Who cares about these Babas? They can die. Ooh. This one's fun. I like this one because it's simple. I actually forgot. Oh, Meta Winnie, thanks for the donation. I just gave my teacher money. There's no proof that I'm your teacher, and don't say that. I don't have BTTV. I thought I did. Maybe it's installed in my other, like, Windows account. Anyways, okay, let's look at this. Baba is me. Flag is nothing. And then the grass is stopped, so I can't even play around with the grass. But there's no walls, so I don't care about walls. They don't do anything. So let's see what I need to do. Well, I'm thinking that if I make the sentence flag is win here, because I think you can share is, then I'm good. So that's what I'm going to do. BTTV is an external program that lets you post emotes like this, but then they're animated. Anyways, Meadow, thanks a lot. Not that I don't appreciate it, but you don't need to do that. So anyways, time to make this sentence. Aha, so see? And then now the flag is win. So this is just the intro stage. And then now, let's see. I think this one is locked. And I need 3 flower thingies. And I have none. So I gotta go over here to the lake for my next lottery ticket. Okay. So here, let's see what we got. Jelly is sink, Baba is you, and now they've introduced this word and. So now Baba is you and Baba sinks. The flag is win, the wall is stop. So I'm assuming if I touch this water, I will sink. So if I break this up, I no longer sink, so I can touch the water all I want. Now here comes another issue. It says that jelly is sink, so if I touch the jelly, I'm gonna sink. And then I can't play around with this because it's in the corner. So let me see what I can do. Well, we have this wall here. Okay, I have the plan. Jellyfish make me sink. I'm gonna try to make the jellyfish turn into a wall. And I'm gonna use that using this and, maybe? But I can't quite get the and. Oh, I should go the other way. So let me move this out of the way. And then now I have the and word. So now I just need to somehow... I don't even know if I can make that sentence. Jelly... Oops. Okay, time for some experimentation. I think if I do wall and jelly is sink, then that just means that it turns the wall into sinking. Oh. That doesn't even do anything. I thought I would sink if I touched the wall. So you guys can't see it, but in this corner it says wall is stop. Man, am I getting filtered in the first actual puzzle? That's not the tutorial? What happens if... I make the flag is the win, and I make the flag the wall. So now the flag is a wall, and that doesn't do anything. Baba, wall and Baba is you. I mean, yeah. Oh yeah, and then I can just feed him to the jellyfish, I guess. Okay, so let's make some room for the sentence wall is Baba. I can't make that sentence. There's no way for me to push it in and then make room for a wall here. Oh, I know, I should just reset. Hold on, how do I reset? Okay, where's reset? R. Yeah. Okay. So if I make myself a wall, then I have lots of me. I can't move. So, oh, I know. Okay, yeah. I see what you're saying. So I need both Baba and the wall to be me. Because if I just say Baba is me and the wall, then that turns Baba into the wall. And then I'm Baba, but there's no more Babas because Babas are walls. Whereas this one, if the wall and Baba is me, then I control both Baba and the wall. Ah, okay, here we go. Now I have... What happened here? Okay, I gotta be careful. I can only move forward, because if I move up and down, then I break the sentence here. So, here we go. Yeah. Alright, where are we? Okay, we're here. The wall is stop, and then that's outside, so I'm stuck in here. The star is sink, and the rock is push. I have an extra and I can play with. Skull is defeat. This is definitely a smart person game, which is why I'm playing it. And then you can't see it, but behind me, it says, whoa. It says the flag is win behind my camera. And then the flag is also outside. So here, if I move this out here, you'll see. Flag is win. And then again, the flag is outside of the wall. Okay, well first I have to at least push the rock out here. And then if I touch the star, I'm gonna sink. And the flag is outside the wall, so somehow I need to get outside the wall or become something outside the wall, like this crab. Okay, so let's do some playing around here. If I make the star a rock, then now it's a rock. Yeah, I'm pretty sure I need to become the crab. So crab and Baba is me, and then I can move the crab and touch the flag down here. Now the issue is, the skull is defeat. And then Snake Star is saying turn it into sink. I don't know what it is, but let's see if I turn the rock into sink, if that's gonna sink the skull. So and then now the skull is gone. And then, oops, accidentally blocked myself. So let me just restart this real quick. So, ooh. So I'm gonna push the skull to here. And then I'm going to change the rock so that it's sink. And then that kills the skull. And then... Whoa, accidentally killed myself. Okay. And now I move this and into here. Oh, whoops. And then I need to move this crab over here. So I think I need to think geometrically how this is gonna work. I need to move this out of the way first. Oops, not that much out of the way. This is an issue. How do I get this crab to be over here? Oh, I just push it down. There you go. So now I'm this crab. So I'm gonna just walk down to this flag that you can't see. And I win. Let's go to 3. Okay, let's see. KK is move. Love is push. Algae is defeat. And then behind my camera window... Actually, you know what? Let me see if I can just resize my window. Because it seems like... Do you guys remember if the puzzle ever went beyond this border? Let me just move myself slightly out of the way. Yeah, it's gamer time. I'm just gonna have this tiny little window for myself. Okay, let me just fine-tune the location of my camera with respect to the game. Okay, so you can see love is win, love is push, love is probably the heart. It says Baba is you in the corner. And then algae is defeat. This is probably algae. And then Kiki is move. So if I move, Kiki, who are these 3 things, move forward, I guess. And then they can interact with the sentences. And then if I touch the algae, I lose. So let's restart. Okay. What I'm thinking is we use Kiki to push the love, because we can push love. But the issue is they only go in one direction. What happens if I do this? Good night, Snake Star. And then I'm going to rearrange Kiki's. So this one is the one that moves left and right. So I'm gonna line it up with the heart. And then change love back to push. And then Kiki can move again. And then it's gonna push the heart out for me, and then I can... Oh, and then love is win, but I can't touch it because it's still push. So let me just change that real quick. Yeah. Okay, let's see. Wallace stop. Flag is win, pillars push. I'm assuming these are pillars. Bob is me. Can't say it here. You can't see it, but this says star is defeat. Baba, is that me? It is me. Okay. Star is defeat. So what I'm thinking is I push the pillars to overlap the flag, and then I turn myself into a pillar so that I'm already there. Okay, so you see this pillar is lined up with the flag, and then I just need to turn into the pillar. So yeah, pillar is me, and then I automatically win. Brick wall. Whoa, zoomed in. Okay, Baba's me, the flag is win, the wall is stop. So I can't even do anything besides play with these two sentences. So here. Baba is me, but what if I also make Baba win? Then I win. Okay, what is this? Secret? Second stage? Extra. Okay. Baba's me. This says the wall is stop. Flag is defeat. Crabs are nothing right now. And rock is push. So notice that if I kept pushing this, I create two sentences, and then I don't know if that's the developer intention, but let's go with that so far. Okay. So now the flag is win. The crabs are defeat though. And then there's two crabs. Because I'm thinking that if I make... How did I choose this name? It's French for calculus. So this is my thought right now. Maybe this will work. But if I make Baba is me and Baba is rock, actually that's gonna kill me because then there'll be, oops, there'll be no more Baba. So maybe I need to make rock is Baba? So now I have two Babas. But the issue is they're both going to die when I touch the crab. Oh, and I don't even... Oh, the crab doesn't even go away? Shoot. Oops. So maybe I don't want to push this rock over here. But then I don't really see how I can make the win condition without also making the crab be defeat. Maxime says you don't need the rock to push the crab in the flag. Okay, let's see what else I can do. I can make the sentence rock is wall, but that just turns the rocks into walls, which this rock into a wall, which isn't gonna help me. Alright, so then this is the critical thinking here. What are things that have to happen? I need to make this a win condition. I need to make flag as a win, or I need to make something as a win. So the only way we can realistically do that is if we push this over. If I do that, then that also makes crab as defeat. So let's see. And even if I run into these, they don't go away. So unlike like water where you sink, okay, first step, break down what you have to do. I need to do this at the very least. If I move this around, then I'm no longer Baba. This has no progress. I have to push it one more time. And then I have two options. I can push this forward, or I can play around with the rock concept right here. So the issue is I can't even move any words from the sentence out of here because the actual rock is in the way. Let's see what else we can do. Not much. Alright, the flag is defeat right now. Is there a way that I can leave Baba in here? Turn this rock into Baba. And then move this over. Try putting the rock in there by becoming the rock. Oh, wait a minute. This rock doesn't even get in the way. Okay, so hold on. Moved around too many parts. Oops. So let's become the rock. Oh, and then now that, whoa, this is a one-time thing. So I thought if I move this would turn back to rock, but I guess not. Alright, so what we're gonna do is I'm going to move this Baba inside. Oh, shoot. Now, there you go, okay. What is this? More secret? Oh man, these are tough. Okay, almost the same setup, but I probably won't do this the same way. Baba's me. Wall is stop. Flag's defeat. Jelly is push. Rock is push. So I have to push this at least one time, at least 2 times. Can I do /VIP? What does this do? You're already a mod, aren't you? Anyways, back to this. Okay. So I can't really manipulate these. I have to go in this area. And I have to push this at least 2 times so that I can play around down here. So crab is now defeat, the flag is win, and the jelly is push. But the issue is, now this crowd's blocking the way. Oh well, let's just play around with this. See, the issue with this is the crab is now defeat. And there's no way to get this set up, unlike the last stage, without making the crab defeat, I think. I'm going crazy, right? There's nothing else I can do. I have to push this at least twice. I can't play around with this sentence because then it's just game over. Maxime. Genshin next? No, never again. Take the jellyfish out and then push the rock back in. How do I take the jellyfish out? So I can't manipulate this sentence, which says Wallace stop. I can't manipulate this sentence because then it's game over. I'm no longer Baba. Sims, Minecraft. I'm not a variety streamer. I don't know. I wanted to keep playing this game a little bit, but we'll see how it turns out. Okay, so like I said, by process of elimination, I have to push this at least once. But me pushing it once doesn't really do anything. I need to push it twice. You can't pull. It looks like pulling, but then I'm just pressing the undo button. So this is just me pressing the undo button. Push, and then I undo. You can't pull. So here I am. I'm here. And then realistically, this only lets me break this sentence up. So if I break this up, then the rock does not do anything. So I can walk through it. However, because the jellyfish is push, I can't really access any of this stuff right now because the jellyfish is in the way. Can I push the entire rock is push sentence out? Yeah, one by one. What am I sacrificing? Were you? Oh, you didn't pay attention. Crab is defeat, so it will always stay there. You can't sacrifice a defeat. Push the entire rock sentence and then use that to get the crab. Oh, I see what you mean. Oops, I think I pushed this in the wrong way. So Jenny is saying we're going to use the whole sentence to get through to the crab. Does this do anything? Oh well, doesn't hurt to try. Oh, if I push, then I run into it. Yeah, it's okay if you don't know how to play, but... I feel like you're onto something though. What's the goal? The goal is to get to win, whatever it is. Right now the flag is win, so I need to touch the flag. The issue is the crab is defeat, so the crab is blocking the way. And then this is what the starting stage looks like. So behind the camera, it says that the wall is stop. So that means I can't walk through the walls right now. They're stopping me. This sentence is Baba is you. So Baba is this little bunny, and then I control Baba. So if I break the sentence up, I am no longer Baba, I am nothing. So I lose, I die. What about rock is me? So if I make rock is me and Baba is me, this is what we did in the last puzzle. But now I am the rock as well. And then we move at the same time unless there's a wall stopping us. Don't search it up. That's no fun. And then... But you see, the crab is defeat, and that just murdered my rock. And then if I walk into it, I die too. If I make rock is wall, then that just turns this one piece of rock into a wall, a piece of wall. Maybe. I don't know if there's room to make that entire sentence, but it doesn't hurt to try. So okay, so what's gonna happen, oops, push that too much. So if I do this, right, I just turn that rock into wall because the sentence behind me says rock is wall. And then if I want to play around with the push, well, now I'm trapped in here, so I can't do that. Now this is content. What level am I on? I have no idea what level this is. This is like a bonus level in the whatever. Make wall as push. You can't. You guys can't see it, but wall is stuck in this corner right here. So there's no way to actually make the sentence wall as push. You can make push as wall, but that doesn't make any sense. This is content though? Kind of. It's gaming content. I've been stuck on this level for like 10 minutes though. 15 minutes at this point. So can you make it so Bava is you, rock is you, and rock is push? I don't think there's enough is's to do that. Because Baba is me, and then, well, actually, let's see. I have an idea that is inspired from this. It's not that you can't use it once, but you gotta think of how the words line up together. So Baba is me. Rock is me. So now I control both Baba and the rock. And you gotta think of how can I make the sentence rock is push. I need to put the rock is push here. There's no other way to make that sentence. Now I guess what I can do is break this sentence. So I'm no longer Baba, I'm just the rock. Yeah. Okay, so Max is saying, I push this rock through. Baba is push. Okay, so let's see. If I just push Baba through using some words. I don't have a Discord yet, RGBT. All right, let's see how this works. Oh, I got it. Okay. Oops, I can't do that because Baba's put. I need to make sure Baba's push. Okay, I've pushed Baba in. Now the issue is, I can't make this sentence Baba is you. But I think we're on the right path here. Let me reset this. So RGBT. This was the game I was talking about. Nice logical thinking. Although you're coming in a little bit later, so then maybe you don't know the premise, but basically we play around with these sentences. So right now, Baba is this little bunny, and it is me. So if I break the sentence, I am no longer Baba, and I am nothing. So I actually just lose the game. Over here, there's some conditions. Essentially, I want to make something win, and then when I touch whatever's the winning thing, then I beat the game. Right now, jelly is push, which means that I can push the jelly. This sentence over here says rock is push, so I can push the rock. Over here, you can't see it, but it says wall is stop, which means that I cannot walk through walls. So as you can see, I can push the rock. And then if I push it twice, then I create the win condition. Flag is win. Now I need to touch this flag somehow. The issue is, crab is defeat. So if I go and touch this crab, I die. So then I also have an undo button. And then we're coming up with this strategy. We can try to push this rock into here. So you see, this is what I was talking about. This game basically has a couple of, quote-unquote axioms, rules that you can do, and then you just need to play around with them and see what you can do. So let's see. I think the plan is we need to get that rock there. So first off, I need to become the rock. So now I'm the rock, which means that I control both the rock and Baba, because Baba is me and rock is me. And then what does Max say? Become the rock, move it to the left of the crab, reassemble the sentence, push it into the crab, blah blah blah. Okay, so I need to move the rock here. Whoa. So I guess I need to play around with this geometrically, because the moment I move this, the rock is no longer me. Well, I guess I can always reform it. I think I've just screwed myself. Is person accepting hints? Yeah, why not? This is an educational stream, so it's less about me exercising my brain than everybody exercising the brain. You can make a rock as you horizontal, by the way. Yes, I could. I guess the problem is right now, I don't want to be both rock and Baba. So now I'm just the rock. But then once I have it here, I should go back to being Baba? If I'm not the rock, and then the rock is on the crab, then it doesn't do anything. You can also use the eyes in is and Baba to make the rock push. Push the rock into the crab right now. Well, first I need to make the rock a push. So what Hamster is doing is he is saying that I can do this, of course. Although, it's kind of an issue because the rock is in the way. So here it is, it's right here. And then let's just use this is, oops. I need to use this is to push the rock into the crab. Reassemble the sentence rock is pushed to the left of the rock crab. Push the rock into the 3x3. Yeah. This is probably not what I'm supposed to be doing right now. Okay, the issue right now is I need to get this is over here. And I can't really play around. I need to move this sentence around a little bit. Because like if I push the is up here, then I can't, it's stuck against the wall, you know? I was okay. Push the whole Baba is you sentence to make more space. Oh yeah. Okay, so here I am. And then I'm getting two different suggestions. Push the whole Baba is you sentence to have more space. So that's what I did. Push the push. The rock cannot be me if I do what Max is saying. And what is Max saying? Push the push to the left. So this is what Max is suggesting. I do this. And then I need to make it so that the rock is me. And then I can't do that. Leave the push next to the left of the rock. Forming the word on the bottom. Can you not replace rock with you? Or you will die. Replace this rock with you. The moment that I break this up, me, am no longer connected to anything. Rock is me. How do I get rock is me without first breaking this up and then me not being anything? Like push the rock on top of Baba. Oh, you mean like this? Oh yeah. Oops. Now I'm a rock. Jeez, that took way too long. It's okay, bonus stage. More difficult than you think it is. Let's do 6. Alright, let's take a look at what's happening. Baba is you. Wall is stop, so that means that I can't alter these sentences. The door is stop, and at the same time the door is shut. The flag is win, so I can't change the win condition this time. However, over here the key is open and I can push it. So I think what that means is that if I push the key to a shut door, it opens. And then, let's see. Now I'm free. And then I can play around with these sentences over here. So first, I open this door because the key is open. And then I can't open this one. My plan is probably I need to make a rock. I need to replace the key with the rock, and then I can use this rock to open this door. Okay. Can you push rock through the first door? Not right now, because there's no sentence saying that I can push rock. I can only push key, but that's what I'm trying to do. I'm trying to make that sentence. So let's see. So here is that one. And then... So now rock is open. Hello, squishing. And then I just need to make that same sentence, but with the rock this time. So now I can push the rock and it is an open. So this now basically acts like a key. And I win. Ooh, area clear. What does that mean? Oh, I get a flower. Twiad? Thanks for the follow. Okay, let's go in numerical order. So let's go to 7. Ooh, okay, let's see. Flag is win is out here. I have an is, and then I can make a couple of sentences. The door is shut, and then I can't change any of these. Okay. So first issue is I need both the key to be pushable and open. The issue is I only have one is. And then once I figure that out, then I just move this so the door isn't shut anymore, so then this doesn't keep me out. Okay, so let's see. So now the key is pushed, but it's not going to open things. Is it in the middle and make a cross? The game is difficult. Make a cross. Like this. I only have one is though. What is happening? This isn't math? Yeah, we're playing a game. A logical game. Okay, so let's make that cross. I just have to be careful with how I push these things so that I don't lose access to any of them. So now the key is pushed and the key is open. And then now I'm here. So now the door is shut, so I can't go through. But if I break the sentence, the door is no longer shut, but the door is stopped. So that's another issue. Let's see if I can make the doors open. Does that do anything if I make the doors open? Nope, the door does not let me through. Oh, I know. Well, maybe I know. Let's see. If I make the door push... Can I push the door? Yeah. Ha 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 ha. There you go. Okay, that was number 7, so let's go to number 8. Alright, so let's see. The flag is win. Baba's me. The wall's defeat. The wall's also stop. And the jelly is also stop. Now, if I break this up, right, the wall is stop. The wall no longer stops me, but the issue is the wall's defeat. So if I touch the wall, I die. And there's no flag in here either. There's no flag in this stage. If I make the wall jelly, then I don't have any more walls. So now I can go through the walls and I'm fine. And then all I need to do is make Baba win. And then because I am Baba and Baba is win, that means that I am win. Yeah. Changeless. Are these titles a hint of what I'm supposed to be doing? Okay, rock is rock. In the corner, Baba's me. In this corner, flag is win. Wall is stop. So I think this is a lesson. Titles are hints. Have you played this game before, Hamster Coder? Whoa. Whoa, Max, what just happened in the chat? So rock is rock, but the flag is a rock. So the moment I move, the flag turns into a rock. And because flag is win and there's no more win, so if I break this, it doesn't even turn back into a flag. Make rock is flag. So if I try this, it doesn't work because the title says changeless. I'm assuming that if you have a sentence like this, rock is rock, then that means that rock will always be a rock. But I can break that. So what happens now? Then I win. Okay. Saw the first few worlds, mostly forgot stuff. Alright, 2 doors. Oh, I'm Kiki this time. There's no Baba. Alright, let's see. The door is shut. The hedge and doors are stop. I have a key. The key is pushable and will open. No Baba, just Kiki. And the flag is win. Okay, so let's clear out some options here. I can't push this key down because then I just lock everything up. Jenny says to make the door me. So let's see. I am now the door. But the flag is not win, so I can't win just yet. Make key is Kiki after the door is you. Hold on. let's make some room. And then let's see what happens if we make the key Kiki. Well, I just turned the Kiki into flag. Ooh, hold on. We got some actual math help right now. Okay, I added 2 more point slope forms in the project. Is that enough? Don't want to add more things, ruin my frog. I recall you saying we should add more. Is that enough? Are they good ones? I think you have like 8 lines now, right? Depends on how good they are. Since Kiki is not push or open, you walk through Kiki. I do walk through Kiki. Oh, now I can make flag as win. Nice. It depends on the quality of the lines, Oliver. Ooh, okay, what are we now? Flag is push. 8 sounds good. Yeah. Like I said, it depends on how well you implement the lines. I have a freestanding jelly. Baba is finally back, and I'm Baba. Flag is flag, so that means that I can't change flag no matter what. Although this time over here it says jellies win, and the flag is a stop. Next area has 1 trick level. Okay. Okay, so let's see the things that I can do. If flag is no longer pushed, then I can walk. Oh, flag is stopped, so I can't walk through. See, the issue here is if I just push this flag, then it's gonna stop by the wall. So then that just locks me in here. Can I make Baba is jelly? I can't make Baba is jelly, but I can make jelly is Baba. So what that's gonna do is that's gonna turn jellies into Baba. So now I'm on the other side. So maybe if I just... Oh, oops. I need to break this sentence right here. Flag is stop. So now... Uh-oh. You know what? Okay, let's see what I can do. Is there a way to just make flag as win? Yeah. So flag is now the win, and then I win. Crab storage. Alright, flag is push. Here's the flag. The door is shut and stop. Baba's me. Baba is open. Wait. So if I touch the door, do I just die? Dang. And then there's a whole bunch of Baba stuff is here. So I have a feeling I need to stack some things, push them all up, and then I create 3 sentences at the same time. Okay, first off, it'd be really nice if I could make Baba's win. But if the moment I break this... Wait, does this even matter? Hold on. Oh, I can't do that because look. The moment I push this into Baba's defeat and I am Baba, I die. So I can't do that. Let's see, can I... What happens if I make the flag open? Then I can use the flag like a key. I'm going to trust you, Jenny Yeehaw. But what's the point of you being a mod if you don't know how to do mod stuff? Oops. Okay, I now have the crab. So I can push the crab through. Oh, and then this one stops me because now Baba becomes a crab and I die. You remember Changeless? Yeah. So what are you implying here, hamster code? Yeah, Baba's nice, and then... Oh, I have an is right here. So then, if I do this, then Baba will always be Baba. But then what happens if I do this? Oh, it doesn't work. Okay, first come, first serve. You need help with math? What's 1 plus 1? I don't know, it depends on certain background information. But I don't know, first, let's just say if you're just talking about regular numbers, then 2. Factorial? Factorial is just taking all the numbers that come before that number. So for example, 5 factorial, then you just take 5, 4, 3, 2, 1, stop at 1, and then you multiply them all together. Comes up a lot in like combinatorics problems. So they just shorten the notation to a factorial. Alright, last stage for this area. Burglary. So I gotta steal stuff. So Baba's me. Door is stop. Key is defeat. The win is out here. I can push the star. The key is open. The wall is stop. And then I can also make a shut sentence. So let's see. For something to be opened, it needs to be shut. Alright, the door isn't shut. Well, let me move this out of the way, and then if I make the wall shut, then that means that I can break the wall, a piece of the wall with the key, right? Woo, what just happened? Oh, key's defeat, so I can't touch the key. But, okay, forget the key. Because what if I make the starfish open? And then since the starfish is also push, then I can open this wall. And then now I just need to make a sentence and make something a win. So first, I should probably make the key a win. But then, just to be safe, let's make sure that it's not also a defeat. Yeah, and then I win. Ooh, we beat an area. So does that mean I unlock the next one? This one? Solitary island. So what is 0, 0? Poem. Oh. Rose is red, violet is blue, flag is win, and Baba is you. And then the wall is stop. So I can push this, right? And then now, violets are win and I'm the flag. So I can't even do anything if I push it down. Baba's win would be nice, but the issue is, if I push it up, then I'm no longer anything. And then I can push is. I can't push these because then I'm no longer anything. And then if I push the U, then I just become the flag and then I can't do anything. So logically, I need to push the is down. I can push it down a couple of times. And then if I push the violet in, then I unlock the rows to use. And then now I'm the rose and Baba's win. Where are the roses? Oh, here they are. Okay, so I just need to touch Baba. Float. Oh, Baba's float. Oh, this is a new word. So what does that do? The wall is stop, rock is push, flag is win, Baba's you. So the wall still stops me. I can still push. But I can't touch the flag because I'm floating. Okay, float. You can interact with anything like sink, win, defeat, etc. Stop still interacts with me though, and I can still push stuff. Okay, why don't I just become something that's not Baba, so then I don't have to float. What if I just become the wall? Oops. So now I'm the wall, and then I can just touch the flag. Ooh, let's see. Water is hot. Baba is you and float. In the corner here, Baba's melt. Skull is the defeat and the float. Flag is win. So if I touch this, oh. Right, I'm floating, so I don't have to touch the water. But the skulls are floating, so do we float on like, you know, the same level? Yeah, I guess so. Okay, what if I make the water float? Then does that mean that I won't interact with it because I'm not floating? Oh, oops, that's not how you build the sentence. So, you see, now these are floating, and then I can just touch the flag. You much smarter person. I would hope so. I don't know if, Hamster, you came here from like the Twitch search for Baba's You, but if you read my about, I'm a math teacher, so Yeah, the levels are easier because they're just like an intro to the world. So they're probably just teaching me lessons about float and stuff. But yeah, that's why I wanted to play this game, because I wanted to see how good I would be at it, which seems just to be medium. Okay, this is an extra stage. Let's try it out. Get to the red areas. There's a trick level there. Okay. Let's see. Baba is you and float. Water is water, so I can't change it. And it's hot. You can't see this, but it says water is water and hot, and then it says Baba's melt. Let's see what I can do. Baba's me and float, so I don't need to touch the water, but then if I touch the skulls, I die, because the skulls are also float. I can make myself not float, but then that means I touch the water and then I melt. So let's see, is there anything I can even do right now? What was the stage of this? Melt and float. Baba is melt and you. I'm already melt and you, and also float. Okay, my idea is I make a bridge somehow. If Baba is melt and you, then you have an extra is, right? Okay. But how do you propose I get and you down here without dying? Because the only way I'm Baba is if this stays together. Push the entire sentence down. Here we go. So now I have these 3 words to play around with. Can I do this? Water is float. Oh, okay, here we go. Nice. Water is Baba for Baba Army. Oh yeah, I could have done that. Okay, you want me to get to the red. Okay, I'm gonna try out this, and then we'll see. Text is float, so that means that I can't play with the text, right? Oh, I can. That means that the text... Rock is push, Baba is you. What does this do? Nothing. not much to work with. Rock is you. Oh, right, now oh, okay, I see. The issue was I couldn't get the 2 rocks. Uh-oh. Okay, I just need to play this right. So I need to... Who called it math? Called what math? Like, who decided to call the subject of math the word math? I don't know. Okay, so this is the plan. We are going to make a bridge, sort of. The issue is this rock, I can't push it out. So the idea is, I'm going to make the rock me, and then we can sacrifice the rock. Nice. So the difference is the rocks are floating. So that means that they aren't going to do anything. And then I still die. If I don't make them pushable, then I can walk through them, but then I just die because of the water. Do words sync? Oh. Then why don't I just sacrifice these? Oh, that's why they were float earlier, and then... Okay, okay. Okay, I made it to the red hamster coder, and then I'm gonna call this the last level, because it's been a while. So you said that there's something interesting going on here. Water is sink, Bob is you, cog is push. These are cogs. Text is float. So if I break this, Win is probably going to explode, right? Because then it won't be floating. Not in this first level? Okay. But I'm still gonna call it here. So let's see. I can use the cogs. And then if I push it one more, I die. Okay, I'm gonna go and answer my tests. What do you mean answer your tests? Are you in the middle of a test right now? Can I just push it out like this? And then I just need to get the is out, right? Whoa. Okay, so what happens if I just make text as win? Does that mean if I touch any text, I win? I can't touch text. Hold on, hold on, hold on. I can make Baba as one, right? Thank you, Jenny. Oops. There you go. Nice. Okay, I'm gonna call it there, guys. Thanks for tuning in. Thanks for watching my first gaming stream, actually. And sorry if you were here for the math. But I know it's hard to see in my channel, but even if I'm in the middle of playing a game, feel free to ask a question, and then I'll just, pause the game and then answer your math next time. I don't know. I like this game. I might play it again on Sunday. Or maybe try a different puzzle game, who knows. But thanks for watching, everybody. I'll see you guys later.